Here we're looking for all the solutions in 0 to 2 pi. So we're looking at the entire unit circle, 0 to 2 pi, not including 2 pi, for this equation. And then we're going to find the principal root. So the principal root will be a different solution. So we'll do that one in purple. The principal root's the one that's going to use only the restricted domain of our tan function that gives us a tan inverse. So let's start with all solutions in the 0 to 2 pi. So I'm just going to solve this equation starting with 8 tan x plus 7 radical 3 equals negative radical 3. And I'm going to subtract 7 radical 3 from both sides in order to get the term with the x by itself. So on the left I get 8 tan x, and on the right I get negative 8. So if there's a nothing there, that means there's an imaginary 1 right there. Not imaginary, but invisible. Negative 8 radical 3. Those are like terms. And then I can divide both sides by 8 to get that tan of x equals negative 1 radical 3. I'm going to scoot that over to make my space for a tan inverse. And then I'm going to take the tan inverse of both sides so I can get x by itself. So the way to get that x out is to take the inverse function. So then the tan inverse and the tan cancel. And on the left I have x. And on the right, I think, okay, on my unit circle, and remember I'm looking for the entire unit circle for our blue solution. So on my whole unit circle, when is tan inverse equal to negative radical 3? So that's thinking of tan as sine over cosine. So I'm looking for when it's radical 3 over 2 over 1 over 2, or, whoops. So that's negative radical 3 over 2. I'm sorry, over 1. So I'm looking for the ordered pair on the unit circle that has a negative radical, let's see, y would be the second. 3 over 2 and 1 over 2. One of them negative and one positive. So there's one point, and the other would be this guy. And those 2 points on the unit circle are, let's see, a negative x and a positive y. Taller than it is wide, since the radical 3 over 2 is bigger than 1 over 2. And then positive x, negative y would be here. So those are my two real solutions. So that is, let's see. See, this one is 2 pi over 3, and this one is 5 pi over 3. So in 0 to 2 pi, I have two solutions. In 0 to 2 pi, I have x equals 2 pi over 3, or x equals 5 pi over 3. So two solutions there. Okay, and then I'm asked for the principal root. So the principal root means I need to go back to this tan function and think, okay, well, when is tan inverse defined as an inverse function? Where is that restricted domain? That was from negative pi over 2 to pi over 2. So looking at just the right hand of the circle, that corresponds to this point right here, right? This point is not on that side of the circle. And we, instead of taking that positive 5 pi over 3 angle, we want the negative angle, because our tangent goes from negative angles. So that would be let's see, negative pi over 3 would be that little angle. So our principal root is x equal to negative pi over 3. And that's our third solution.